What does TC mean?
Tri-Cities.
Tri-Cities, Richland, Kennewick, Pasco. Okay, what does W mean? Wenatchee River. What does C stand for?
Chelan.
Lake Chelan. What does T stand for? Twist. Methow River. What does O stand for? Okanagan River. Oh, we don't have one here. This is the Columbia River. Right here. You have to remember that. What's the M stand for?
Hey, here's his book.
What is that?
Missoula.
Missoula.
And this is glacial Lake Missoula, which was 1,800 feet deep here and 1,400 foot deep at Missoula. Okay, what does S stand for? Spokane. Okay. How about DF with a GC under it? Grand Coulee and Dry Falls. Dry Falls and Grand Coulee. Okay, that's the Quincy Basin right there. Okay, and this says TF. What's that for? Palouse Falls. Okay.
No, there's a PF right there. That's the PF.
They're together, one on either side of the
I got it.
falls.
Okay, I got it.
Okay, what's W2 stand for? Okay, what does WG stand for?
Wahula Gap.
Wallula Gap. Okay, how about
wow.
T? And this is Eugene, Springfield right here. And this is L. Longview. And A. Where Claire's from. So I'm standing in the Pacific Ocean, except that I'm 300 to 400 feet lower when the floods are coming. As 30% of the world becomes covered with ice, the ocean goes down, maximum of 400 feet. Now, I'm going to review those drainages for you with one small bucket of water, and then you may need some help. I want to thank Bruce for working a year and a half or 2.5 years to make this happen. I can't sure. And especially for his hours this morning digging and carrying water. And I want to thank you all for coming. So just for review, this is Clark's Fort right here, coming from Missoula down that way into glacial Lake Missoula, which is dammed by the Purcell Lobe. These two sticks are an ice dam, dammed by the Purcell Lobe of the Port Erin ice sheet coming south out of British Columbia. And this is the Columbia River, which is not going to play a role at all because it's covered with ice. And this is the Okanagan Lobe coming down and blocking the Columbia River from going to Wenatchee at times. Not all the time, but some of the times. And then here we have the Okanagan River and the Methow River and Lake Chelan and the Wenatchee River, etc. and Yakima River. Now, the problems we had this morning were rocks, but we could deal with that. But the thing that we really couldn't deal with, and we've been pouring buckets on this all morning to try to saturate the ground. You may notice if you measure the depth of your well tonight when you go home, you'll find that the level has come up a foot or two, recharging your axis, which is good because it's been so dry. Anyhow, so this is an extremely gentle gradient, which made it very challenging. And if you're a good geography, notice that we have terribly shrunk the entire Columbia River drainage basin. The thing's way too close than they should be. So I'm going to need...
This is, let's point out, this is the Snake River here.
Oh yeah, I didn't say that. Thank you. That's the Snake River. So one of the things I might say right now is that when the Missoula floods come along, they send water. If that was not blocked there, water would go up the Okanagan and would go up all these rivers right here. And there's something that this is vantages right here. So water's going to go through Grand Coulee, which is there, and part of it's going to go straight to the Tri-Cities, but part of it's going to go through the Quincy Basin, and that water is going to rush up the Columbia and partway up some of these rivers. It's also going to rush up the Yakima River, way up, all the way to Yakima. It's going to rush up the Walla Walla River, all the way to Walla Walla. It's going to rush up the Tucannon River, if you've ever heard of that. It's going to rush up the Willamette Valley, all the way to Eugene, Springfield. And perhaps most amazing of all, it's going to rush up the Snake River into Hell's Canyon, all the way to the mouth of the Salmon River, which is an elevation of about 1,400 feet. The fact that there were pre-existing large rivers like the Columbia and the Snake and the Clearwater and the Salmon meant nothing to these floods because it was 18 cubic miles of water per hour. And then the Lula Gap, which is right here, cut that discharge in half, and that was for about 3 days. The Lula Gap cut that discharge into half. So the water was only 400 feet deep in Portland. Portland. Yeah. I mentioned that the water was 900 feet deep plus at Lula Gap, and that it backed the water up. So that made the water in this vicinity back up farther than anywhere else. Lake Lewis got about 800 feet deep, which that's why there was more water. I mean, if there hadn't been Lula Gap, there still would have been water going up back rivers. But this dam at Lula Gap made it go farther up the Yakima, farther up the Snake, farther up the Walla Walla than it would have otherwise.
It also deposited lots of silt. That's why Yakima is so fertile.
Yes, the Tushy beds, which are the fine-grained sediments, sand and silt, that were deposited as the sediments settled out of Lake Lewis, are extremely fertile. Very, very good farming. They don't make the Palouse Hills, which is silt and is also very good, but they do make what are called the Tushy beds, named for Tushy, Washington, flood deposits. The flood made two kinds of deposits. One was sand and silts that are rhythmically bedded that are outstanding for farming. The other is these giant gravel bars. So you can guarantee, just look around you, the state of Washington is going to be the last state of the union to ever run out of gravel. So 14,000 years ago, at 5 to 50 year intervals. That's how long it took glacial Lake Missoula to fill up from glacier melt, rainfall, and rivers coming in until it once again was deep enough to float its ice dam.
So the ice dam floated, and that's what made it.
Oh yeah, thank you. So the temperature of the lake was something above freezing. Let's say it was 35 Fahrenheit or 2 Celsius or something like that, whereas the ice was at 0. So you had thermal erosion at the base of the ice dam. As soon as the lake got to 1,800 feet, it floated the 2,000 foot thick ice dam, and water starts pouring under it. Watch a video called, the same thing happens in Argentina. I'll show a picture tonight. On the internet, do a search of Lake Argentina floods. Lake Argentina floods. This glacier comes out of the Andes and goes right across Lake Argentina and separates it into two parts, and one side gets up high until it floats the ice dam, and then amazing pictures, usually with Indian music. The bed of the Columbia River is at 300 feet. The top of the reservoir behind McNary Dam is at 340 feet. The top of the gap is at 1,140 feet. And at 1,120 feet, and there's a picture of my dog sitting on it in one of my books, there is a granitic erratic carried by an iceberg, 900 plus feet above the riverbed. So, and the water through the Lula Gap was going approximately 100 kilometers an hour, 60 miles an hour. They made these amazing gravel bars up tributary canyons that nobody's ever written down. Well, one person. Okay, I forgot to mention this iron bar. I hope somebody can take this home and either use it as a sculpture or straighten it out and use it, but it definitely should not stay here. This is the drainage divide between the Palouse River and the Snake River, which come together at the northern end of Walla Walla County. What happened was that the ancestral Palouse River, which actually starts over here in Idaho, and I didn't put it on here, but the ancestral Palouse River comes out of Idaho, and it used to go straight to the Tri-Cities along this channel right here. But this drainage divide between the ancestral Palouse and the ancestral Snake is low enough so that the floods overwhelmed the ancient Palouse River channel and spilled over into the Snake River, and what's left is Palouse Falls. So this represents that drainage divide that used to be there at Disney World. Okay, I'm going to need people to augment the flow. So when I point at you, start putting some water in, okay? Gradually. So Columbia, a little faster on Glacial Lake Columbia. There we go. Start putting some water in there. There we go. That'll add to Glacial Lake Columbia. We can start putting water in there because that will be the water going through the Quincy Basin. That's good. Keep going, everybody. Look at the water coming up the Snake River. Isn't that great? And there's water going up the Yakima River. Empty all those buckets. Empty them all.
Go, Karen, go.
Keep going. Let's go. Oh, it's water coming up the Willamette Valley. It's going to Astoria. Good work, team. It came up the Walla Walla River. It came up the Yakima River. It came up the Snake River. Beautiful job, everybody. Whoa!
Go, river, go.
Woo!
That looks cool.
Good work, everybody. Serious. Continue going to that, obviously. That is great.